Good morning friends, welcome back to my channel Coding Environment. In today's video, we're gonna solve the next linked list problem, linked list cycle. It is also one of the Leetcode problem which states that given head, the head of a linked list, determine if the linked list has a cycle in it. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So let me explain this problem with an example. So if you see this is the example number 1. So this is one of the linked list given, and you can see it. The head is pointing to node 3 and 3 is pointing to 2. Similarly, 2 is pointing to 0 and 0 is pointing to -4. But this -4, instead of pointing to null, it is pointing to one of the previous node, which is 2 in this case. So this one is creating a cycle in this linked list. So in this case, we have to return true. Similarly, if you see this next example where 1 and 2 is given, right? So this 2, instead of pointing to null, it is again pointing to 1. So this is again creating a cycle, and we have to return it as a true. Similarly, if this is an example where it has only one node, in this case, we can simply return it as a false because this is not creating a cycle. So how we can solve this kind of problem? So this is also a very known problem where we have to detect the cycle in a linked list. Now, to solve this problem, we have basically 3 methods. Let me explain all these methods one by one. So in this method 1, what we can do, we can use a simple hash set in it. So just assume that you are creating a hash set, and what we're gonna do is, so just assume that you are creating a hash set, and initially this hash set will be empty. Okay, so what we're gonna do is we're gonna create an empty hash set, and we will traverse this given linked list one by one. Now once we will go to this node, we will try to find that this node is present in this hash set or not. If it is not present, we will add this node in this hash set. So we are going to add the first node, which contains 11, right? Now again, we will move to the next node, which will having 12, right? Now we will search this node is present in this hash set or not. If it is not present, we will gonna add this node into this hash set. Again, we're gonna move to the next pointer and see that this next pointer, which is 13, is present in this hash set or not. It is not present, so we will keep on adding this new node also in this hash set. So we're gonna do the same thing unless until we're gonna reach till this 19th node. So just let me create a hash set, and I'm gonna add all this node one by one. So see, from here 13, it will move to 14, from 14 to 15, 15 to 16, 16 to 17, 17 to 18, and 18 to 19. So in all these cases, it is going to search that the present node is present in this hash set or not. So if you search 14, it will not present, right? It will not be present. Similarly, if you search 15, 15 will also be not present, so we'll go and add it. If you search 16, 16 will also not be present, we will go and add it. Similarly, we will search for 17, and similarly we will search for 18 also, and for 19 also. But after this 19, what will happen? The next pointer will point to this 14, right? And now the moment you're gonna see that this node, this 14 node, is present in this hash set or not, it is gonna give you that 14 is present, right? Here 14 is present. So in this case, we're gonna return the true. So the logic is very simple. What we have to do is we have to first create an empty hash set and then keep on traversing the given linked list through this head pointer. Now, if the current node is not present in the hash set, we're gonna add this current node into the hash set. We're gonna keep on adding this current node into the hash set. Now, at the end, only two things can happen. The 19th node can point to one of the previous node, or it can be pointing to null also. So if it is pointing to null, it means that there is no cycle present in this linked list. But if this last node is pointing to a node which is already present in this hash set, it means that there is a cycle present in this given linked list. So this is one of the method by which we can solve this problem. So what is the space complexity and time complexity of this solution? If you see this time complexity, because you are traversing one time the full linked list, the time complexity will be n. Also, the space complexity, if you see, you're gonna save all the nodes of the given linked list into this hash set. So it is going to again consume the n space, right? So in this case, the time complexity and the space complexity both will be order of n only. Now, moving to the next solution, you can say a solution 2. In this case, what we can do, we can modify the given structure of the linked list so that it will have an extra parameter which will say that this node is visited or not. So it is a Boolean parameter which will say that the node is visited or not. So what you're gonna do, suppose this node has two parameters, right? One is like int data, you can assume, and the second one is the node next, right? What we're gonna do is we're gonna create a Boolean variable which says that it's visited or not. And every time you're going to traverse this linked list, you're going to mark the current node as a visited. So suppose the head is here, right? Now, in this case, you're going to mark this as a visited as a true. And then again, you're going to move to the next node and see if it is visited or not. If it is not visited, you will mark it as a visited. Similarly, for 13 also, you're going to mark it as a visited. For 14th also, you're going to mark it as a visited. 15th also, you're going to mark it as a visited. 16th also, you're going to mark it as a visited. One thing we have to first see that before marking it as a visited, we have to check that this is visited or not, right? So because all the nodes by default will be false, we're going to mark all the nodes as a true. And the moment you reach till 19th, right? 19th is pointing to your 14th node. Now, the moment you traverse from this node to this node, you will see that this node is already visited because we have marked this visited variable as a true, right? So if your last node is pointing to a node which is already visited, by checking this variable, we can say that it is visited or not. If it is already visited, we will say that the linked list has a cycle, and if it is pointing to null, it means the linked list has no cycle. So it's very simple. We're going to modify the structure of the node and insert one extra variable into it, says that visited or not visited. It's a Boolean variable, and we will traverse the complete linked list. Now, if sometime, if anywhere during traversing, we find a node which is already visited, by checking the condition of this variable, we can say that it's visited or not, right? So if it is already visited, we will say that it has a cycle in it. And if there is, during the full traversal, we're going to find this as a null, we will say that there is no cycle present in this given linked list. Now, in this, if you see, the time complexity is again n, and space complexity, if you see, you're going to basically modify the given structure with one variable, right? So you can say that n of how many bytes the Boolean will take, the extra byte, right? So that many bytes it gonna consume for this space complexity. But the biggest demerit is that you have to modify the structure of the given linked lists, which is not very good approach. So moving to the last option or the last solution, which is the most efficient solution, which is also known as the Floyd solution. Floyd or tortoise and hare solution. Okay, so this is a very simple solution where what we're gonna do is like we're gonna create two pointers, like one will be your fast pointer and one will be your slow pointer. Okay, and initially the fast pointer and the slow pointer will be pointing to your head itself. Now we will traverse this given linked list. The only thing which you're gonna do is the fast pointer will move two nodes at a time, and the slow pointer will move only one node, okay? Only one node at a time. And once it will move, we're gonna check is my fast pointer is equal to my slow pointer. If this condition is satisfied, we will return it as a true. It means we have found a cycle in this given linked list. And if it didn't happen and we completed our for loop or while loop with that iteration, it means that there is no cycle present into that given linked list. So let's run this as a dry run and let's see how this is working. Now, initially your fast pointer and slow pointer both was pointing to your head itself, right? Now, the fast pointer in the first iteration, it will move till 13, right? So your fast pointer is basically here. And your slow pointer will move only one pointer, right? So your slow will be here. Now, the fast pointer from here, it will move from here to here, right? This fast pointer. And the slow pointer again is going to move only one. So slow pointer will be here at this point, right? Now, again, the fast pointer will move two nodes at a time, right? So it will move till here. So now your fast pointer is at the 17th, right? And where is your slow pointer? Your slow pointer will move only one node. So it will move till 14th here. Now, again, your fast pointer and slow pointer is still not equal, right? So it will keep on doing that operation. So the fast pointer will go two nodes at a time. So fast pointer will move here and your slow pointer again will move here, right? Now, if you see your fast pointer, it is moving two nodes at a time, right? This fast pointer is moving two nodes at a time, and your slow pointer will move one node here also, right? So at this time, your fast pointer is here and your slow pointer is still your fast and slow pointer is not equal. Now, your slow pointer will move only one, which is at the 17th, and your fast pointer from 15th will again reach till 17th. So here at this point at 17th node, your fast pointer and slow pointer will be equal, right? So in this case, when you compare, you will see your fast pointer and slow pointer is equal. It means you have found a cycle in a given linked list. So this is a very famous approach to solve this problem. There's also a two-pointer approach, or you can say a Floyd's approach or Floyd's algorithm, tortoise and hare algorithm. So all these are named for the same approach or same algorithm. And for the reference, I have given the code here. You can check it. So here also we have just created one slow pointer and fast pointer. We are running a while loop here unless until we don't reach any null pointer or my slow pointer is not equal to the fast pointer. Now see here, if my slow pointer is equal to the fast pointer, I will return it as a true. And my fast pointer will move two nodes at a time, whereas my slow pointer will moving only one node at a time. So this is a very simple example or very simple algorithm to find a cycle in a given linked list. I hope you understood this problem. If you have understood it, please write understood in the comment section and like this video. Also share with your friends. See you next video. Till then, have a great day and goodbye.